Below, in this lecture, we find out the area of a square. In the drawing, we have a right triangle, triangle ABC is a right triangle. Inside this right triangle, we have this square DEFG. In addition, we know that side AB of this triangle ABC, of this right triangle, triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. Again, our mission is to find out the area of this square DEFG. So, first of all, we will implement the Pythagoras theorem in the right triangle ABC in order to find out the length of the hypotenuse AC. Okay, so according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, the hypotenuse in the right triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle, triangle ABC, AC square equals to AB square plus BC square. Here by PT is a equation from Pythagoras theorem. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. In conclusion, we found out that AC square equals to 25 plus 144, that is 169. So AC square equals to 169. Here we take a root out of this equation, and finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13. In the next step, we define the length of this line segment BG as X. So what is the length of line segment GC? From the drawing, it is very easy to see that GC equals to BC minus BG again. BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is X. So in total, GC equals to 12 minus X. In the next step, we define the length of one side of this square DEFG as L. So all the sides of this square DEFG will be equal to L units in their lengths. Why? Because of the fact that all the sides of any square are equal to each other. In the next step, we define the size of this angle ACB as alpha, and we focus on this right triangle, triangle ABC. In the right triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. So the missing angle equals to 90 degrees minus alpha. So we define 90 degrees minus alpha is beta, and therefore the missing angle here equals to beta. Here we have the equation that 90 degrees minus alpha equals to beta. If we add to this equation alpha and then we subtract beta, we get that 90 degrees minus beta equals to alpha. In the next step, we focus on here we have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Again, the sum of the angles on one side of a straight line is equals to 180 degrees. We can implement the rule in our drawing. We have line segment AC. This line segment AC is the hypotenuse of the right triangle ABC, and because of the fact that AC is the hypotenuse, it is absolutely a straight line. So AC is the straight line. So if we focus on the lower side of this straight line AC, it's point E. Here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line AC at point E to 180 degrees, the missing angle here must be equal to 90 degrees in its size. Likewise, we'll focus on the lower side of the straight line AC at point D. Here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus this missing angle. This missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees in its size. In the next step, we'll focus on the small right triangle, triangle ADF. This small right triangle, triangle ADF. In the small right triangle ADF, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle equals to alpha. Likewise, we'll focus on the small right triangle FGC, the small right triangle FGC or EGC. This is the small right triangle EGC. In the small right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Here, therefore, the missing angle equals to beta. BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. BC is a straight line, so if you focus on the upper side of the straight line BC at point G here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G here? We have this angle that is beta, this angle that is 90 degrees, plus the missing angle. So in total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on the upper side of the straight line BC at point G must be equal to 180 degrees. So the missing angle here, this missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle here equals to alpha. In the next step, we'll focus on the small right triangle, triangle FBG. In the small right triangle, triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. So in the drawing we have in total 4 right angles. 1, 2, 3 in the right big triangle, triangle ABC. Actually all the 4 right angles are similar to each other according to angle similarity rule. Why? Because each one of the 4 right angles have exactly the same 3 angles, alpha, beta and 90 degrees. That is to say all the angles of one triangle are equal to all the angles of the other triangle. They are correspondingly equal to each other according to angle similarity rule. So for example, this small right triangle FBG is similar to the big right triangle, triangle ABC. So write it down, the big right triangle, triangle ABC is similar, this is the sign of similar, to the right small triangle FBG. This small right triangle FBG. According to angle similarity rule. And from the fact that the 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that BG over FG in the right small triangle FBG is equals to BC over AC in the right big triangle, triangle ABC. I repeat again, we derive that BG over FG equals to BC over AC. BG is X over FG. FG is L, and it is equals to BC, that is 12, over AC, that is 13. In conclusion, found out that according to equation 1, x over L equals to 12 over 13. Here we will multiply this equation 1 by L, and finally we will get that x equals to 12L over 13. Again, according to equation 1, x equals to 12L over 13. Likewise, this small right triangle EGC is similar to the big right triangle, triangle ABC. So write it down. The right big triangle, triangle ABC is similar to the right small triangle, triangle EGC according to angle similarity rule. And for the fact that the right big triangle ABC is similar to the right small triangle EGC, we will derive that the following relationship exists between their sides. We will derive that GC over GE the right small triangle GEC is equals to AC over AB in the right big triangle, triangle ABC. Repeat again. We derive that GC over GE equals to AC over AB. So GC equals to 12 minus x over GE. GE equals to L, and it is equals to AC. AC equals to 13. It is the hypotenuse of the big right triangle ABC. So it is 13 over AB, that is 5. In conclusion, found out that according to equation 2, 12 minus x over L equals to 13 over 5. Here we cross multiply this equation 2, and we get that according to equation 2, 5 times 12 minus x equals to 13L. Here we'll open the brackets on this side of this equation, equation 2, and finally we will get that 5 times 12 is 16, 5 times minus x equals to minus 5x, and it is equals to 13L. Here we add 5x to this equation, equation 2, and we get that according to equation 2, 60 equals to 13L plus 5x. And again, according to equation 2, 6 equals to 13L, 60 equals to 13L plus 5x. Here we subtract 13L from this equation, equation 2. And we get that according to equation 2, 60 minus 14L equals to 5x. Here in this equation 2, we substitute x here by the value of x that we found in equation 1. According to equation 1, x equals to 12L over 13, therefore we substitute x in this equation 2 by 12L over 13 from equation 1. We'll do it now and we'll get that 60 minus 14L equals to 5x, and x according to equation 1 is 12L over 13. In conclusion, found out that according to equation 2, 60 minus 14L equals to 5 times 12L is 60L over 13. Here we multiply this equation 2 by 13, and finally we get that according to equation 2, 60 times 13 is 780, minus 13 times minus 13L equals to 169L, and it is equals to 60L. Here we add 169L to this equation 2, and finally we'll get that according to equation 2, 780 equals to 60L plus 169L equals to 229L. In conclusion, found out that 780 equals to 229L. Here we divide this equation 2 by 229, and finally we will get that L equals to 780 over 229. 780 over 229 is equals to 3.40611. We check that I'm not wrong. $780 over 229 equals to 3.40611. Indeed. So N equals to 304.0611 units. The area of this square DEFG is equal to the area of one side squared. The area of one side is L, and therefore the area of squared is L squared. So the area of square DEFG equals to L squared, and L is 3.40611, therefore L squared is 3.40611 squared. So in total, the area of square DEFG is equals to 3.40611 squared. That is actually equals to 11.6016 square units. And that is the answer to the question. Repeat again. The area of this square DEFG is equals to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEFG. So in the drawing, we have a right triangle ABC. Side AB of the right triangle ABC equals to 5 units in its length, side BC equals to 12 units in its length, angle ABC equals to 90 degrees, it is a right angle. Inside the right triangle ABC, we have this square DEFG. Again, our mission is to find out the area of this square DEFG. So, in the first step, we implemented the Pythagoras theorem of this right triangle ABC, in order to find out the length of the hypotenuse AC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, so AC squared equals to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. In conclusion, we found out that AC squared equals to 25 plus 144, that is 169. So AC squared equals to 169. We took out of this equation and finally found out that AC equals to 13 units. That is to say, the length of the hypotenuse AC is 13 units. In the next step, I presented to you a rule that states that the sum of the angles on one side of a straight line is equals to 180 degrees. AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of the straight line AC at point E, here, the sum of the angles must be equal to 180 degrees. So which angles you have at the lower side of AC at point E? We have this angle that is the right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles in the lower side of AC at point E to 180 degrees, the missing angle must be equal to 90 degrees in its size. Likewise, if we focus on the lower side of the straight line AC at point D here the sum of the angles must be equal to 180 degrees, according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. In the next step, we define the length of BC as x, the length of line segment BG as x. BG equals to x units in its length according to our definition. So what is the length of line segment GC? GC equals to BC minus BG. Again, GC equals to BC minus BG. BC is 12, BG is x, so in total GC equals to 12 minus x. And in the next step, we defined the length of one side of this square DEFG as L. So all the four sides are equal to n units in its length because of the fact that all the sides of any square are equal to each other in their lengths. And in the next step, we defined the size of this angle ACB as alpha, and we focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So, the missing angle must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, and therefore the missing angle equals to beta. So we have the equation 90 degrees minus alpha equals to beta. If we add to this equation alpha and then subtract beta, we get that 90 degrees minus beta equals to alpha. In the next step, we focus on this small right triangle, triangle AFD. In the right triangle AFD, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. Likewise, we focus on the right small triangle, triangle EGC. In the right small triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. In the next step, we focus on the upper side of the straight line BC at point G. BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So we focus on the upper side of the straight line BC at point G. Here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So each angles we have at the upper side of BC at point G, we have this angle that is beta, this angle that is 90 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta, but 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. In the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. So actually, in the drawing we have in total 4 right triangles. 1, 2, 3 in the right big triangle, triangle ABC. All those 4 right triangles are similar to each other according to angle similarity rule. Why? Because each right triangle has the same, all the 4 right triangles have the same 3 angles that are alpha, beta, and 90 degrees. So they have the same angles, all the angles of all the 4 right triangles are correspondingly equal to each other. Therefore, those 4 right triangles are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to this small right triangle, triangle FBG. Repeat again. The big right triangle ABC is similar to the small right triangle, triangle EBG according to angle similarity rule. And from the fact that the big right triangle ABC is similar to the small right triangle FBG, we derive that the following relationship exists between their sides. We derive that BG over FG equals to BC over AC. And again, we derive that BG over FG equals to BC over AC. BG is X, FG is L, BC is 12, and AC is 13. In total, we found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, found out that actually that X equals to 12L over 13. Likewise, the big right triangle ABC is similar to this small right triangle, triangle EGC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that GC over EG in the right small triangle EGC equals to AC over AB in the right big triangle, triangle ABC. Repeat again, triangle ABC is similar, the big right triangle ABC is similar to the small right triangle EGC according to angle similarity rule, and therefore the following relationship exists between their sides. GC over GE in the right triangle EGC equals to AC over AB in the right triangle ABC. GC is 12 minus X, EG is L, AC is 13, and AB is 5. So in conclusion, we found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here, of course, multiply this equation and equation 2, and finally found out that 5 times 12 minus X is equals to 13L. Here we open the brackets on this side of this equation, equation 2, and we actually found out that 5 times 12 is 60, and 5 times minus X equals to minus 5x. So in conclusion, we found out that according to equation 2, 60 minus 5x equals to 13L. Here we added 5x to this equation, equation 2, and finally found out actually that 60 equals to 13L plus 5x. So here we subtracted 13L from this equation, equation 2, and found out actually that 60 minus 13L equals to 5x. So here we substitute x in this equation, equation 2, by the value of x that we found in equation 1. According to equation 1, x equals to 12L over 13. So we substitute x in this equation, equation 2, by 12L over 13 from equation 1. We did it, we found out actually that 60 minus 13L equals to 5x, and x is 12L over 13. We found out actually that 60 minus 13L equals to 5 times 12L over 13. So 60 minus 13L equals to 5 times 12L, that is 60L over 13. So we found out that 60 minus 14L equals to 60L over 13. Here we multiply this equation, equation 2 by 13, and finally found out that 13 times 60 is 780, and 13 times 1 minus 14L is minus 169L, and it is equals to 60L. So 780 minus 169L equals to 60L. Here we added to this equation, equation 269L, and finally found out that 169L plus 60L is 229L, that is equals to 780. Here we divided this equation, equation 2 by 229, and finally we found out that L equals to 780 over 229. 780 over 229 is 3.40611. That is to say, L, that is the length of one side of this square DEFG, equals to 3.40611. And the area of any square is the length of one side squared. That is to say, the area of this square DEFG will be equal to L squared. Repeat again, the area of square DEFG equals to L squared. L is 3.40611, therefore L squared is 4.40611 squared. And 4.40611 squared equals to 11.6016 square units. In conclusion, we found out that the area of this square DEFG equals to 11.6016 square units. Okay, thank you very much.